Now we'll take a look at the last two sample problems in this lesson. Now, generally speaking, I'm probably not going to spend a lot of time getting detailed points on this using a T-chart. If that makes you feel more comfortable, that's fine. What I really want to focus on more than anything is how do we identify what the asymptotes are, and then just drawing a basic curve to meet those asymptotes. And so we'll just go ahead and take a look at this really quickly. First of all, the a value is a 1, so this is just the standard reciprocal function. The curve is not getting farther away from the origin, or in this case where the asymptotes cross. It's your standard reciprocal function curve. Now we have x plus 1, and remember that h is always opposite, so this is going to go back 1. Well, that is going to tell us what our asymptote is. So basically what we're looking at here is we're looking at an asymptote of x minus 1. So we have x equals negative 1 as one asymptote, and then we have y equals to negative 2. The k is a negative 2, so the y equals to negative 2 is going to be our other asymptote. Okay, so if we plugged in a basic 0 for x, you could see 0 plus 1 is 1, 1 over 1 is 1, 1 minus 2. So we're roughly going to get this value right in here. And of course we're going to try to keep this as close to the asymptote as possible without actually touching the asymptote. And we have a similar situation here. And again, this is just a quick and easy sketch. I'm really not trying to be too detailed. If you wanted to see a better visual of this, you could always grab it on your calculator and you could see it right there. Now let's take a look at the other parts of this question. It says identify the domain and range. Well, the domain is going to be all real numbers except any value that makes the denominator equal to 0, and so you could see a negative 1 would make this equal to 0, so x cannot equal to negative 1. Okay, and so we could write that in that way, or we could write that in interval notation, and you could see it written like this. So if you remember interval notation, we could say all values to negative 1 but not equal to negative 1, and then negative 1 and all values to positive infinity, and you could see it written like that. And the range would not be together altogether too different. We're going to have all real numbers, except this time y cannot equal to negative 2. And so you can see the asymptote really dictates to us the values that are excluded from the domain and the range. And again, if I wanted to write that in interval notation, you would see it like that. So that's basically, and of course the horizontal and vertical asymptotes, we've got that already. So let's take a look at sample problem number 3. This one's quite different. It says, what is the graph of f of x equals 1 over x? And of course, if you remember, the reciprocal function that we were dealing with earlier was just 1 over x. Now we're asking for f of x equals 1 over x squared. You could go ahead and plot points of this, but I want you to think about this from a logic standpoint. If we did this, if a normal reciprocal function looked something like this, but we were squaring the x now. So we have f of x equals x squared. So what happens here, 1 over x squared, whenever we square the x, if the x is negative, then we square that negative value, it actually ends up being positive. So our graph ends up actually looking like this. It flips the left-hand side, and so we can see that the domain and range are similar, and the equations, the vertical and horizontal asymptotes, are similar. We just get this flipped version of the negative values, and so you can see how does that change from f of x, there's a missing f of x, equals 1 over x. How is it the same? Well, it's different because the negative x values now have positive y values, and so that would just be a good generic way to state that. And so it's kind of an interesting little graph, and you could also do that on your calculator as well. So, alright, that's a good quick look at some different types of graphing with reciprocal functions.